Good evening, mindsetters, and welcome to our action-packed show. We're going to try and do every question that we found that you sent to us. My name is Jacques Duplessis, and before I start with our first question, I would also like to just a big shout out for Liberty for their sponsorship of the show. Without that sponsorship, this show would not be possible. So I think as a country, thank you, Liberty. Okay, folks, our first question I want to look at was sent to us by Oratile Motoahai. I hope I said that correct, Oratile. If I didn't, please forgive me. Okay, the question is on the screen. It deals with a parabola that was given, and then underneath that parabola, they've squeezed in a little rectangle PQRS. Now, they've told us the equation of this parabola is y equals x squared. Okay, there's our little rectangle, and just to make our life a little bit more difficult, they gave us the coordinates of r as 6. So from 0 to r, we have 6 units. But then look at how sneaky they've become. They said 6 minus x is the coordinate for q. So that means if I go to 6 and I get x, go x back, I'm at q, which then means that this little part there is indeed x units long, this line QR. Okay, so the question then carries on, and it says that, we have to find the point P in terms of x. Now let's quickly see where point P lies. Point P is over there on the screen, folks. Now, point P lies on top of the parabola. So what do we know? We know the coordinates for point P. We already know that the x coordinate for P is given. It's given to us as 6 minus x. So if I were to write down the coordinates for point P, I will say the x coordinate is 6 minus x. And then how do I find the y coordinate? Well, I substitute the 6 minus x into the parabola. Remember, that's always the case. If you have the equation of the function, you have the relationship between the coordinates that lies on the coordinate pairs that lies on the function. X is x. In this case, they gave it to us as 6 minus x. And they tell us here to get to the y value, all we need to do is square the x. So this will be 6 minus x all squared will be the y value for point P. Okay, I think we've got enough information. We've got point Q. Point Q is given to us over here. So let me write it down here. It's 6 minus x and the point 0. So now we've got the first part done, and it was, for a lousy 1 mark. 6 minus x and then 6 minus x all squared. Okay, so that's the first part done. The second part, they're asking us, determine the maximum area of this rectangle, the maximum area, not just the x value. They actually want the maximum area. Okay, so let's see the process. Can I write down the area of this rectangle over there? And the answer to that is indeed I can. The area of this rectangle in terms of x is going to be this base length, which we know is x, multiplied by the height. Now the height there is the y coordinate of P. So that will be, now please note folks, this is squared. So whether I've got 6 minus x or whether I have x minus 6, because I'm squaring it, it is irrelevant whether it's 6 minus x or x minus 6. So I'm doing that for convenience sake, so I don't have to change the sign later. Okay, let's have a look. If I now multiply that out, I get x multiplied by x squared. 6 times x times 2 is minus 12x plus 36. I take the x in, I distribute it, I get x cubed minus 12x squared plus 36x, and that is the area of that rectangle in terms of x. Now remember, to find the maximum area, that area is represented by a cubic curve. Okay? If you look at the equation, its power is 3. It's a degree 3 equation. So that represents how the area of this particular rectangle is going to behave as we move point P along the parabola. To find the maximum area, I need to differentiate that equation, make it equal to 0, because that's where my optimum value would lie. So let's do that. We go into phase 2 of the problem. A prime x is equal to 0, and if you want to be really fancy, you can say to optimize the area, because the area is given to you as a cubic function. So that gives us 3x squared minus 24x plus 36, which is equal to 0. I can clean this up a little bit. I can divide by 3, so I get x squared minus 8x plus 12, which is equal to 0. Now, folks, we've been factorizing quadratics since we were little babies in mathematics class. So we've got an x there, the signs are the same, they're both negative. What times what gives me 12 and adds to 8? And the answer to that is definitely 6 times 2. Okay, so x will equal 6 in this case, or x is going to equal 2. Now, let us go back to the graph and decide which one of those two answers we're going to use. Or we can use both, possibly. Let's have a look. If you look at the graph, this line here, the green line I'm drawing in, is the line x equals 6. So if it means that x is 6, then it means the length of this side here must be 6. Then we don't have a rectangle. We have a flat green line that lies on the x-axis. So this is definitely not applicable to what we're trying to do in this question. It is an answer to the equation that we're solving, but it does not apply to the context in which we're working. Okay, so we're going to use x as a value of 2. Now, folks, please don't fall in the trap here. Okay, we don't put the x back in here, because that would mean we would make x4 in the equation that represents area. And we just found this little side here to be 2 units long. Let me just color it in. That is the answer that we were looking for. Okay, so we need to go back to the area. We need to make x2, and we see that it's 8 minus 4 times the 12 is minus 48 plus 72. Now, 8 minus 48 gives me minus 40, plus 72 gives us an area of 32 units squared. Okay, Oratile, I hope that helped you to see how to work with this. The catch was the 6 minus x. The fact that they gave us the 6 on the outside and then say come back x units and you have point Q.